Now that I've defined for you what arithmetic progressions and geometric progressions look like, and by the way, you'll see me use those terms interchangeably, progressions and sequences, they all mean essentially the same thing for this course. We need to know how to identify when something is an arithmetic or geometric progression. Now remember, 1, 2, 3, 4, 5 and ones like those are very easy to identify. Sometimes they're not as easy. We have these two rules up the top that you can see. And something will be an arithmetic progression if we have 3 terms, or however many terms. If we take t2 minus t1, and then t3 minus t2, so the second term minus the first, and then third minus the second, if they are equal to the same thing, then we can say that those 3 terms form an arithmetic progression, which basically means that they'll have a common difference. Similarly, something will form a geometric progression if we can do the same thing, except instead of subtracting the sets of terms, we divide them. So if we have t2 divided by t1 and then t3 divided by t2, so the ratios between the terms, if they are equal, then we can say that we have a geometric progression. And just off to the side here, I've just got those formulas from the previous talk before, just so you know when we're applying them. Coming down and looking at some questions now. The first one of these says, find the first term and common difference for the arithmetic progression with t10 equals 18 and t20 equals 48. Now, right off the bat, I know that I'm going to need to use some simultaneous equations for a question like this. You can see that in 2 separate cases, I'm given the number of terms that this term correlates with, and then also the term itself. If I go up to this formula, for each of these, I'm given this, and I'm also given n, but I'm not given a or d. And that's the whole point, because you can see the question's asking me to find that. So I know I'm going to need to form simultaneous equations. And so what I do with this first one is I go up to here and I say, okay, well, 18 is equal to I don't know a, plus n minus 1, which is 10 minus 1, so 9 times d. I'll call that my equation 1. Also, for this second one, I can say 48 is equal to that same a, plus, and now it's 19 times the difference, and I'll call that equation 2. Now, if you remember from simultaneous equations, hopefully from previously, I'm not going to go into too much of the details on why I'm doing what I'm doing, but I'm going to subtract 1 from 2. Now, if it isn't clear why I'm doing this, again, I'd recommend going back and learning some of those previous topics. But essentially, this eliminates this variable. So what that gives me is 19 minus 9d, which is 10d, is equal to 48 minus 18, which is 30. 30 divided by 10 is 3. So my common difference in all of these terms is 3. Now all I need to do is to pick one of these equations that I started with and substitute back in my d to find the a, right? And I'll just pick the first one just because it's got smaller numbers. And so I have, in equation 1, I have 18 is equal to a plus 9 times 3. 9 times 3 is 27. Taking that away from 18, I get that a is minus 9. See that off. Right, so my first term is minus 9, and my common difference is 3. Okay, moving on to the second question now. Find the first term and common ratio of the GP with T3 equals 16 and T6 equals 128. Very, very, very similar question, but I just need to use that slightly different formula. Right, this one up here. Tn is a times r to the power of n minus 1. So using that with this first thing that we're given, we can say that 16 equals a times r to the power of n minus 1. So 3 minus 1 is 2. And then for this one over here, we have 128 equals a times r to the power of, well, now it'll be 5 because we have 6 minus 1. So that's equation 1, that's equation 2. Again, simultaneous equations. I'm not going to go into too much detail on why I'm doing this because we're going to be focused on this content specifically. But I'm going to divide these two. 2 divided by 1. And that's going to mean that I have a divided by a, which is nothing. That's just 1, sorry. R to the 5 divided by r squared, which gives me r cubed. And then I have 128 divided by 16, which is 8. So that means that my r is equal to 2. Right? And that gives me my final answer for the rate. Now, just like I did with the previous question, I'm going to substitute that r value back into just one of these equations. And so I'll just pick the first one because it's got smaller numbers, easy to deal with. So I have 16, I'll sub it into 1. 16 is equal to a times 2 squared. 2 squared is 4. Dividing both sides by 4 gives me a is equal to 4. Right, so that gives me my first term and my common ratio for that geometric progression. All right, Third question. Show that log base 5 of 6, log base 5 of 12, and log base 5 of 24 is an arithmetic progression. Alright, so this one's a little bit different. I'm showing that something is a progression. This is where these things that I was talking about before come in handy. I would recommend kind of not memorizing, but understanding exactly how these work. So if I want to show that something is an arithmetic progression, I essentially have to take the middle term, subtract the first, and then find the last term, subtract the second term, and show that that forms the same thing. Now, if I label these, each of these as T1, T2, and T3, all right, what I'm going to do is go T2 minus T1, and that's going to give me log base 5 of 12 minus log base 5 of 6. And if you remember your log laws, well, that means that if we have two logs with the same base, we can, and we're subtracting them, we can write this as a one log with that same base, and in here is going to be the division of those two things that were inside. So in this case, 12 over 6. And in that case, we're going to get log base 5 of 2. So that's the common difference between those first two terms. Now what I want is to be able to do that between the other two terms and show that this is the same thing. So let's do that. I have T3 minus T2. And in this case, that's now going to be log base 5 of 24 minus log base 5 of 12. And I can follow the same process. So this is going to be log base 5, and now instead of 12 over 6, it's going to be 24 over 12. And that is also log base 5 of 2, because 24 over 12 is equal to 12 over 6. Now, important thing to note here, I haven't completely answered my question. You've got to be really careful with how you write an answer to something like this. So what I've shown is that there's a common ratio, which is basically 90% of the work. But the question doesn't ask to show that there's a common difference. It asks to show that there's an AP. So what I say, because there is a common difference, this is an AP. Right? And that's how I'd answer a question like that, to make sure that the marker understands, that you understand how to answer it.